Okay, let's do some more applications of these linear systems. Now this one's nice because they've already set it up in a table for us. This is a flooring company making linoleum in a standard size roll. These rolls are then cut into small, medium, and large tiles according to one of 3 available cutting patterns. So they've already put the patterns across the top and the number of rolls down the side in a column and organized the information here. And it says how many rolls should be cut according to each pattern if they want to fill an order for 2,000 small tiles, 3,400 medium tiles, and 1,400 large tiles. So we actually just need to take those values, put them in for the total small, medium, and large areas there. And the equations basically write themselves from this setup. So it was really nice how this one was given to us. So I'm going to go ahead and just steal that information and come down here that we have 20A plus 80B plus 40C equaling 2,000, 25A plus 90B plus 100C equaling 3,400, 50A plus no B's plus 20C equaling 1,400. So that those numbers are coming from, those coefficients are coming from if they were cutting these certain types of patterns, how many they could get. So if they're cutting pattern B, they can get 80 small tiles and 90 medium tiles and no large tiles because of just the way that those patterns lay out on the roll. So anyway, we've got these 3 equations. We want to solve these for A, B, and C. And our normal technique is to pick on one variable and eliminate it twice to get down to a 2x2 system. On this one though, don't work too hard. Which one of these variables is the easiest to get rid of? Do variable B, because it's already gone in the 3rd equation. So I can already just use that equation as one of mine in my 2x2 system. If we can just get rid of the B by combining the top 2 equations, that's all we really need to do for that step. So what I'm going to do is I'm going to take this top equation and multiply it by 9 and the second equation by -8 to create opposite B coefficients there. Okay, so what that'll give me is 180A plus 720B plus 360C equals 18,000, and -200A minus 720B minus 800C equals -27,200. Add those 2 together and the B's will cancel. It will leave me with -20A minus 440C equals -9,200. So now for my second step, I'm going to take the 3rd equation, the 50A plus no B's plus 20C's equals 1,400, and my new equation that I've created, -20A minus 440C equals -9,200, and I'm going to work with those. Okay, I need to either get rid of the A's or the C's right now. I'm going to personally pick to get rid of the C's because I can turn a 20 into a positive 440 to cancel those out if I multiply this by 22. If I multiply that top equation by 22, then I'm going to get 1100A plus 440C equals 30,800. Bring the second equation over, -20A minus 440C equals -9,200. Add those together to cancel the C's. That will give me 1080A equals 21,600. Divide by 1080 on both sides. And although these numbers are very large, that actually comes out beautifully as A equals 20. Now I want to work my way back up, resubstituting in. Now that I know A, I can go back to one of these 2x2 equations, sub that A value in to find C. I'm going to choose the top equation there because all of the coefficients are positive. So I'm going to choose, I'm at a green level here. So I'm going to choose to do 50 times A, which is 20, plus 20C equals 1400. So 1000 plus 20C equals 1400. Subtracting 1000 from both sides gives us 20C equals 400. And then dividing by 20 gives us that C also equals 20. So we have a 20 of the C pattern, 20 of the A pattern, and now we need to go up and find B. So we have to use one of the first two equations because the third equation doesn't have any B's in it anyway. I'm just going to choose the very top equation. So 20 times A, which is 20, plus 80B plus 40 times C, which is also 20, equals 2000. So this gives me 400 plus 80B plus 800 equals 2000. So I've got 1200 plus 80B equals 2000. So 80B is equal to 800. B is equal to 10. So we've found A, B, and C. Depending on how they ask you for your answer, they may ask you to just give them those three values, or as an ordered triple, they would go in their correct order of A first as 20, B next as 10, and C last as 20. Okay, so let's just try one last problem. And again, we're only going to do the setup here because the setup tends to be the hardest part. So on here we have Ace Novelty wishing to produce 3 types of souvenirs, souvenir A, B, and C. To manufacture type A requires 2 minutes on machine 1, 1 minute on machine 2, and 2 minutes on machine 3. Type B requires 1 minute on machine 1, 3 minutes on machine 2, and 1 minute on machine 3. Type C requires 1 minute on machine 1, 2 minutes each on machines 2 and 3. There are 3 hours available on machine 1, 5 hours available on machine 2, and 4 hours on machine 3. How many souvenirs of each type should Ace Novelty make in order to use all of their available time? Okay. So one thing to notice, and it's in bold print here for us, that they switched from minutes to hours. All of these times are in minutes, and then the overall times are in hours. So we're going to have to definitely do a little bit of adjusting when we get there. I would recommend setting up a chart here. Again, this is the hardest part a lot of times. So what I'm going to put across the top are the types. So we've got type A. I'm going to make a column for that. Type B in its next column. Type C in a third column. And then across the rows, I'm going to put the minutes. The machines. So we have a machine 1, a machine 2, and a machine 3. So let's see. Type A, it says, requires 2 minutes on machine 1. So I can put a 2 in this first box. It requires 1 minute on machine 2 and 2 minutes on machine 3. So those are all going to get A's variables with them because they're all in the A column. Type B requires 1 minute on machine 1, so a 1 in this next box. 3 minutes on machine 2, and 1 minute on machine 3. And all of those are going to get B's with them because they are in the B column. Type C requires 1 minute on machine 1 and 2 minutes each on machines 2 and 3. So again, going across, these are all in minutes. So what I'm going to put in my very last column, I'm going to make one more column, which is the total minutes, the total time in minutes. So if I follow this first row across for machine 1, I've got 2A minutes, 1B minutes, 1C minutes, and that has to equal up to 3 hours. So 3 hours, if I multiply that by 60, I would get 180 total minutes. Machine 2 has 5 hours available, so if we convert that into minutes, that would be 300 minutes. And machine 3 has 4 hours available. Converting that would be 240 minutes. So again, now that we've got everything organized, we could pull this information out of the chart and have our equations that we want to solve. So we would have 2A plus 1B plus 1C equaling 180. 1A plus 3B plus 2C equaling 300. 2A plus 1B plus 2C equaling 240. And at this point, you could start picking on your variables and solving this set of equations.